Good afternoon, my name is Anton Korobeynikov and I'll let you know about some new feature which was added to the latest LLVM 2.3 release. It's new LLVM Compiler Driver. First of all, I would like to note that the implementation itself was made by Mikhail Gushenkov from Codagers, and I did the overall planning for this project and also the mentoring of it. So, here is the outline. First of all, we'll speak about the motivation for this project, why we need a compiler driver at all. Then I'll describe different ways to solve the problem of building a compiler driver, so with some examples. Then we'll proceed to the requirements for the compiler driver, so which features should it possess and so on. Then I'll give a short outline of the high-level overview of the llvmc2 compiler driver, and in the end I'll proceed to low-level details of the compiler driver infrastructure, so everyone can try to build a some custom compiler driver by himself. So, what's compiler driver? From the first point of view, compiler driver is pretty easy and dumb tool. So just some tool which execute a sequence of different tools in some chain and grab some set of input files and produce output file. But it's not so simple, because it should be able to deal with mix of different inputs, because as usual, user usually wants, for example, to feed different input files to the, for example, to the C compiler. So we usually see the mix of C sources, the object files, the libraries, and so on in the input. And compiler driver should be able to deal with all these files and select a proper way of compilation for all these files. So also, as there can be many different tools in the compilation pipeline, and all these tools can have their own set of different options. The compiler driver should know about all these tools and all these options in order to dispatch all needed options to the correct tool and nothing more. And also, there are many other small and not so small things. For example, it should know about the creation of some temporary files and invocation of different tools and so on. Why we need compiler driver at all at the LLVM? First of all, LLVM is pretty huge. It contains many different libraries, and many different tools can be built on top of these libraries. We also have many tools shipped with the LLVM itself. And also LLVM is flexible. So these tools also has enormous amount of different options. So you can control and tweak almost every feature, and there are many knobs and so on. And this is good for the developer, because it can, for example, take the input bytecode, feed it into the optimizer tool, select needed optimization options, and then produce bytecode and so on. That's good for developer, but not for users. End users usually want all-in-one solution. So they don't want to deal with mix of different tools and invoke each tool with all those specific arguments. Usually users want all-in-one solution. So they have their normal compiler, and they want just a drop-in replacement for their own compiler. So everything should work out of the box. And this this was one of the motivation for the compiler driver, because we want to substitute the GCC with all the LLVM tools. So, for example, on the Linux platform, we don't have currently the link time optimization, because the Linka support needs Linka needs to know about bytecode format, how to glue the things together, optimize them, and so on. And this was done on the Darwin platform, but not on the Linux. And consider we want to substitute the default Linka, which is invoked somewhere deep inside the during the GCC invocation with the special flavor of the LLVM Linka, so it can merge the bytecode files, do optimizations, and emit something. This is a small example how the compilation pipeline can look like. For example, we always have many possibilities. Consider, for example, we have a C source file. We can compile it via different ways currently. We can feed it via LLVM GCC or via Clang. Also, at the end, the output of the LLVM GCC, we can have a bytecode, and we can, for example, optimize it and have a bytecode as the output. We can output bytecode, feed it via LLC, and either have an assembler or consider we finished some binary emission tool. We can even want to have a binary at the output. Also, we might want to take this bytecode and feed it into the input of the LLVM link and link with other files, and after that do some link time optimization. Or there can be possible many other edges. So, for example, we might want to use the output of opt to use the input of the LLC, and so on. So, let's proceed with the possible solutions for the compiler driver. One possible solution is just some handwritten driver. The typical example for this is the Apple GCC's driver, which used it to select different GCC variants for different platforms. So you can, at the same time, for example, compile the code for the x86, for the PowerPC, and so on, and then glue things together to get one universal binary, and so on. Well, this approach works fine in its own field, but nowhere else. So it's not flexible at all, and we cannot use it in general. Another bad variant is the old LLVM Compiler Driver, because it was too weak and has only limited set of features. So previously you have just some compiler, linker, and nothing more. So all these approaches are not suitable at all. GCC currently uses some special language for describing the compiler driver. It's called specs. In general, this approach works, but the syntax of this language is a little bit ugly. So if anybody tries to work with it, knows what I'm thinking about, what I'm talking about. And also, the problem is when you need to add some, for example, command line option, you need to introduce changes into different parts of the compiler. So it's not usable at all. And the fourth approach is the fully featured build system. For example, consider we want to take some build system like scones and so on, and use it to build a compiler driver on top of it. This approach works, but this is the overkill for this solution is pretty big. So all these solutions in general works, but they're not suitable because either they are ugly or have some external dependencies, and so all this has some problems. But from this we can at least grab some ideas. So, what are the requirements for the compiler driver? First of all, compiler driver should be easy configurable. So it should provide some language so we can define all different ways how the set of input files is transformed via different tools into set of output files, and how all different options are handled, and so on. Also, we don't want extra dependencies. So no Perl, no Python, no extra scripting languages. So we shouldn't enforce the user to install some third-party software to run compiler. Also, it can be good if the compiler driver will be reconfigurable at the runtime. So we can just add some different compilation paths on fly. Also, it should be flexible and universal. We should be able to deal with all different crazy tools and all those options. For example, the current compiler driver was modeled to be a substitution for the GCC. So we need to deal with all different options and all different knobs. And there are also many other requirements in general. So, what we propose. The compiler driver, the overall design of the compiler driver was partially inspired by the scones toolkit. So it has same notions of tools, actions, and so on. We already have some description language in the LLVM. It's called TableGen. So we decided to use the TableGen language to describe the compiler driver because we already have parser for this language, and thus we just implemented a TableGen backend which converts the description of the compiler driver into set of C++ files. It's pretty natural to describe the logic of the compiler driver as a graph, and because we already have some chains of the compilation. Also, compiler driver selects the best compilation way automatically. For example, there can be several possibilities to compile a same set of inputs into outputs. And thus we can, for example, select the path which contains lower amount of tool invocations. And surely the compiler driver is driven by the set of input files and command line arguments. What is the graph-based approach which I talked about? So, tools which are used into the compilation forms nodes in the transformation graph. So we call this compilation graph. And edges in this graph, they define possible transformation paths. These edges are weighted, so weight depends on command line of set of input languages and so on. It's some internal actually thing to the compiler driver because the compilation path with maximal weight is used. I won't say much about this, so if anybody interested in exactly what weight is and how it's calculated, you can consult the documentation. This is a high-level overview of the compiler driver itself. First of all, we have a set of configuration libraries which are used to populate the compilation graph. So they define configuration libraries actually define the different ways how the set of input files are compiled. So from this set, the compilation graph is built. Then from the compilation graph, set of possible supported options is extracted. And this set of options is used to pass command line arguments. Yeah? And also the set of input files, set of options, which are driven by the command line arguments and compilation graph itself, forms the set of actions which are needed to compile the set of input files into set of output files. So this is the high-level overview how the current compiler driver is working. Let's proceed to the low-level details. So actually, I will try to describe how one should write the compiler driver descriptions and build their own compiler driver. First of all, as everything is driven by options, we try to summarize all different flavors of different command line options used by the GCC. First type of options are pretty easy. It's just a switch option which acts like a Boolean variable. And another possibility is parameter option, so it has some, name and value. The extension for the parameter option is just when the name is same, but the value can be just list of possible values. Another thing is prefix options, so you don't have this assignment explicitly. Rather, you have some prefix and the arguments. They can be some delimiter, they can be blank delimiter, and so on. The extension of this is prefix option list, so you have the same prefix but different values. And also we include some options aliases, so you can, for example, wire one option into another. So it can be used to build a set of shorter options. Yeah. How one should define the set of options? It's pretty easy. So here we define the we define the three options. We define the action, which is used how to forward this option to the tool. And also we define the help string for this option. Currently we have two possible variants. In this example we have two possible variants of actions. So this action of forward is pretty simple. We just need to forward this option as is to the tool. Another variant is the unpack values. So it's used to forward this form of options to the tool. So compiler driver will just forward the value of this option to the tool. So, and in this example, those three description of options will make the following support. So we can build some sort of Linka, for example. Next big thing is tool. Tool is the heart of the compiler driver, actually, because tools form the nodes of the compilation graph. And tools describe how exactly the input file will be transformed into the output file. So tool is actually the list of different properties. You can define the input language, the output suffix. So you can define the command line. There are some variable substitution into this command line. I'll speak about it a little bit more further. And also you can define the set of options here. So for example, this is description of typical compiler, because it has some, as you see, compiler, and sync means that all unused options of the compiler driver will be forwarded to this tool. So it's pretty normal for compilers because they can have all those crazy options. You can use some crazy things into the command line strings. Actually, as I've shown before, there were variable substitutions there, so you can have, for example, the input file name and output file name. But you can do even more. First of all, you can use hooks to construct command line. So this thing will just invoke user-provided functions here and substitute what they are returning into the command line and then execute this. For example, this can be used to implement, well, a similar thing like the Apple's selection of different architectures. So you can use these hooks to select the path to the toolkit. In the same way, you can you can also forward the environmental variables here. So pretty easy. Also, there is conditional execution. So you can use some case construction to do some switches on the input options and alter the source, the command line in the same way. More about the case construction later. Also, normally a tool is just a thing which transforms one input file into one output file. It's pretty common for the compilers. But consider we want to implement some description of Linka. Linkas are a little bit unusual because they take the set of input files and transform them to the one output file. For this description, you can use a special join property. So it just indicates that compiler driver will collect all input files here and forward to the tool at all. Currently, we have one limitation, so these join nodes can be only the last in the compilation chain. So the last one is, so the linker is the last, so you cannot, for example, chain two linkers together, but this can be surely resolved. Next thing is the compilation graph. Compilation graph is used to define the different transitions, so you can chain the tools together. The syntax is pretty easy, so you just use the declaration of tools to connect from the magic root node, and define different paths of the compilation. They can be also optional edges, so which are enabled only if some options are provided into the command line. Yeah, and in this example we have path from the root to the C compiler or to the assembler. At the end of the C compiler we can run the LLC tool and do the optional optimization here, and also we can proceed from the LLC to the assembler and then to the Linka. So just easy example of the how things can be compiled from the C source via LLVM tools to the binary file. Next thing is the language map. Language map is used to map different input file extensions to the input languages. Consider, for example, we have the set of C++ source files. C++ sources can have all different extensions. These. So it will be pretty inconvenient to define the tool for each extension separately. Thus, we have the notion of the input language, and in such map, we just map extensions to the set of input languages. So as I've shown before, tools have input and output languages defined, and output language is used mostly for type checking. So compiler driver won't allow you, for example, connect the tool which produces the LLVM bytecode to the tool which compiles the assembler. And also you can introduce the checks on the input language and change the way of compilation. So for example, introduce the additional paths into the compilation graph based on the input language, or for example, alter the command lines based also on the input language. Option list is the easy way to separate tool-dependent and tool-independent properties of command line arguments. For example, usually we want to, well, for example, in the early beginning of the our definition of the compiler driver, specify just help strings for all the tools. And then, because these help strings don't depend on the tools itself, so just a property of the options. Also, we want into the one place define all aliases and so on. And option list provides such pretty useful feature. So in the option list, you can define the help strings at all, and you can also set if this option is required or not. And also aliases are supported here. And then in the tools, you don't need to provide the help strings at all, and you can in the tool descriptions focus on to the semantic properties of the options. Condition execution. Currently we have one construction used for the altering of the command line arguments or to introduce different nodes into the compilation graph. This is case language construction. There are different tests available, so you can, for example, introduce tests based on the command line arguments, based on the input language. There are some Boolean expressions, so you can combine different conditions and so on. And then use this case language construction to change the command line, for example. There are many different tests used for the case construction. They are all listed into the documentation of the llvmc tool. Also, there are some examples there. So, thank you. I just note that the compiler driver itself was firstly modeled as the drop-in replacement for the GTC. So it can be possible that we missed something or did something wrong, and we really need your feedback. You can find the detailed documentation at the llvm.org website, or, for example, look into the directory of the compiler driver itself. Also, there are some examples, and I would like to tell that current implementation is flexible and rich enough to act as some substitution for the GCC, so it will be able, for example, to introduce different transformation tools into the compilation pipeline. So, thank you. Questions? Yeah?
As a future direction, have you guys considered maybe actually compiling the various components together? It seems like kind of in the spirit of LLVM to actually take the compiler and various other parts of the pipeline and actually basically custom compile, and also you'll be able to, of course, eliminate all the dead code pieces that aren't necessary in the whole pipeline, sort of build a custom compiler slash linker for every build scenario.
Well, the question is whether we consider to build a custom compiler for the for different scenarios. So the answer is this is not a good way because, for example, there can be some third-party tools which are needed to be used in the compilation pipeline. Or, for example, there can be huge tools. Consider we want to use GCC somewhere in the middle. So we cannot just take it and compile everything into it. So it will be pretty inconvenient.
You mentioned that the join option can only be used in the last tool in the chain. That's not going to work for me because what I'm doing is I'm creating bytecode, then using the LLVM linker to link it together into a single application, then running ops afterwards so that it does full program optimization, and then converting that to assembly and then converting that to machine code executable.
Well, there was note concerning that the join nodes are currently only the last in the compilation chain. Yes, we know about this limitation, and that's why I mentioned it explicitly. And it won't be hard to cut this limitation at all. So it's not the limitation of design, it's just limitation of current implementation. Yeah.
It looks very much like what Makefile is usually doing. It's using exclusive moves, doing an SPA, how to convert it, send it to your driver, they pause it again, and then transform it. It looks like some duplication of effort. Things that Makefile would usually use, like conversion moves from one side to another, are now in the driver.
Well, the node was there the duplication of efforts. For example, the make can be used for doing some sort of things. The problem is that we need much of conditional execution based on the set of input options and based on the set of input file sets and so on. We also thought about some possible duplication of efforts of build systems and so on, and we made the conclusion that in order to substitute the special solution of like compiler driver with the full-featured build system, it should be flexible enough. And in this case, we will need to force user to use such build system. And I'd want to tell that make currently is not suitable to substitute the even this small implementation of compiler driver. So there are some unique features. So Scones can, but it has a Python dependency. Yeah?
Have you looked at ways of allowing configuration or customization of the interface while maintaining the existing action graph, so that if you wanted to create a driver which had all the same options and all the same actions, but the syntax on the command line were strictly POSIX compliant or strictly compliant with other command line kind of standards, is that something this tool would allow you to do without, again, duplicating effort?
Well, the question is if we can support all different command line syntaxes of options.
Just to specific ones.
Yeah.
Like could you build up two? I mean, not all, but just.
Yes, you can use that sync option to forward all unused options to the tool, and then you can add some custom ones and do custom actions based on these options.
Okay, we can talk about it offline.
Yeah.
So.